Hey, capitalized math industry, and we are going to take a look at a property in geometry called CPCTC. What kind of property is that? Well, it stands as an acronym. CPCTC is actually an acronym. It stands for corresponding parts. Congruent triangles are congruent. So what the property is saying is if two triangles are congruent, then all of the corresponding parts that make up the triangle are congruent. So we're going to do a problem where we're going to solve by using the CPCTC property, and we'll see why it works. So here is our proof. Wait, we're not going to prove it, but we are going to be using something that's like a proof so we can better understand how to solve this problem. So if segment SM is congruent to PM, then angle SMW is congruent to PMW. So if SM and PM are congruent, and angle SMW and angle PMW are going to be congruent, so these two are congruent. Is SW congruent to WP? So that is what we're trying to figure out. So let's rewrite the problem and see where we can get at it. So we already know that SM is congruent to PM. That was given to us. We also know that angle SMW is congruent to angle PMW. That was also given to us. But hang on, with this one, we can state something. If these two are congruent, and there's a line right in the middle, we can definitely say that MW is an angle bisector, because these two are congruent to each other. So we can say MW on the segment is an angle bisector. And the reason why is two congruent angles will bring you a segment bisector. So this right here is a segment bisector. What we can say is not only is a segment bisector, but it's basically congruent to itself. And when we say that, we're going to say that MW is congruent to MW. The reason why we're trying to do that is we can say it's the reflexive property. But the reason why we're trying to do that is we're trying to make steps to make sure that this triangle right here is going to be congruent with this triangle right here. The reason why we're trying to find two triangles is this. CPCTC. If two triangles are congruent, then all of the corresponding parts are congruent. So we're trying to find if SW, WP are congruent. But we can understand that they both can be congruent if only these giant triangles are congruent. So we have to try it out. Get it? Try it out. So if that's a reflexive property, and we know that this is congruent to itself, what we can say is we have a segment, some angles, and a segment. That can tell us, with the proofs that we've been working on, we have an angle, a segment, and a segment. That can tell us, from the last video, we can use segment, angle, segment. We can say that triangle MSW, so triangle MSW, is congruent to triangle MPW. So here's MPW. The reason why is we can say SAS, or segment, angle, segment. So now we have proven that these two triangles are congruent. But hang on, we have one more thing we can do. We said earlier that if two triangles are congruent, which we have, then all of the corresponding parts that make up the triangle, even if they're not listed, are congruent. We can say that this angle and that angle are congruent. We can say that this angle and this angle are congruent. We can say that this angle and that angle is congruent. Say that segment and that segment is congruent. Say that's congruent. And we can say that this and that are congruent. So we can say that SW can be congruent to WP. The reason why is we can literally say CPCTC. That means corresponding parts congruent, triangles congruent. And that is why we can use this property in geometry, where you have some parts of a triangle, and you want to prove that some parts of that triangle make up that are congruent. If you find the triangles are congruent, then all the parts that you find that are opposites can be congruent to each other. And that concludes the video. I hope this video has helped you understand CPCTC. Thank you for watching Top Analyze Math Mystery. Like and subscribe.